guys, today we're going to continue with 2.7 and I'm going to do question 4. So this one's about a girl and a boy on a seesaw. So it says that when they're lifted onto the seesaw is horizontal with respect to the ground, so that's important. That comes in later. Initially the girl's end of the seesaw rises. Her height above the ground is given by this equation. So I'm just going to put this over here. H of t equals a sine nt plus k, and now we've got to find the values of a, n and k. So it gives us some additional information. The greatest height above the ground that the girl reaches is 1.7 and the least above the ground is 0.7. So let's deal with that first. So if we are 1.7 here, the highest point, and then the lowest point is 0.7. And well, it's a sine graph, and we've got to think, well, where would be the middle of those two values? So you can find the average by adding them together and dividing by 2, and that would give us 1.2. So far, what I've got there, it tells me that the girl's end of the seesaw rises first. So that's why I've gone up here rather than down. So it's going to be a positive sine graph. So our A value, that's the amplitude of the graph. And what we see is that to get from the average value to either the maximum or the minimum value is either plus or minus 0.5. So far I've got H of t equals positive, and you don't need to write the positive there, but I'm just going to write it to show that I've considered that her end rises first, sine nt plus k. So far I've got that. Now, in addition to that, I can also add the k value at this point because, well, obviously we've gone up by 1.2. So we will put 1.2 instead of k. And that means the only thing we've got to consider still is our n value. And n, well, n is not the period, so be careful. N is, well, the period is 2 pi divided by whatever's in front of the x. So if we want to find n, well, we're going to have to look what the period is. Now, it tells us here it takes 2 seconds for her to it takes 2 seconds for her to seesaw between these heights. So be careful, because 2 seconds, a lot of people would say that's 2. No, it's not. It takes 2 seconds for her to go from the highest bit to the lowest bit. So in there, that distance is 2 seconds. So then, well, if we want to go all the way to here, we can see that 2 seconds is half of the graph there, and then you've got another quarter there, so that must be 1, and then another quarter there, which must be 1. So in other words, we've got 4. So the period is 4. So that means, well, if we want to find the value of n, we're going to have to say 4 equals 2 pi on n. That means 4n equals 2 pi, and then n equals 2 pi on 4, which means n equals pi on 2. So a lot of people will get that wrong because they'll say that the period is 2 seconds. So watch out for that. Let's pop that in. So pi t on 2. And that would be our equation. So look, it does ask us to find the values of a, n, and k. So we should state those values. We've as good as stated those values, but we need to actually say a equals 0.5, n equals pi on 2, and k equals 1.2. They're asking us for those values, so we need to actually state them, and I will highlight them because we want an answer to be really clear there. All right, so we've done that, and it's handy because we've actually drawn that graph now. Let's see what the next part is. For what length of time during the first 6 seconds of the motion of the seesaw is the girl's height above the ground 1.45 meters or higher? So we've seen quite a few like this, and I'm just going to draw it again so it's clear. So 1.7, 0.7, and 1.2. And we had 4 seconds, which was this. So each second is a quarter of the graph. So it must be 5 seconds, 6 seconds. So this would be 6 and 1.2, and this would be 0, 1.2. I'll put that as a coordinate. And we need to see when we are 1.45 meters or higher. So 1.45 is somewhere here. And again, you could draw that on CAS as y equals 1.45. And then, well, what we're trying to find, and I'm going to colour in those circles because it's including 1.45. So we're saying, when is it, or what length of time do we have that we are here, including those coloured in dots there. So if you were doing it in graphs and tables, you could find those values through the intersection. However, it doesn't tell us to use decimal places, so we are not going to use decimals. We need to use exact values. So I'm going to use the solve function on CAS in main. So this will be solve. So in main, because we want exact. So solve, what's our equation? 0.5 sine pi. I'm going to use x on CAS. It's just easier to find. On 2 plus 1.2 equals 1.45. And then, well, I'm going to have to put a restriction. If I just put comma x here, I'm going to get a general solution. So if I put a restriction and say, well, it was from 0 to 6 that we want, and then comma x, close brackets, and it tells me x equals 1/3, 5/3, 13/3, and 17/3. So what I found is those t values here. So what do we have? 1/3, 5/3, 13 and 17. 13/3 and 17/3, and what you can see is that the space between them is going to be the same because, well, the graph is cyclic. This yellow distance is the same as that, but in any case we'll write that there. So if we're finding the length of time, we're going, well, the time is going to be, well, the difference between 5/3 and 1/3 added on to the difference between 17/3 and 13/3. So it's going to be 4/3 plus 4/3, and that equals 8/3. And, well, you can say 8/3 seconds, or, well, you could say 6 2/3 seconds. We're not putting it to decimals because they have not specifically asked us for decimals. So we only do decimal places when it's specifically asked. Otherwise, you won't get full marks. So there we go, that's that bit. And this is actually really common where you have to find an amount of time above or below a certain value. So that's really good to know. Let's move down. Oh, I think that might be all of it. So that's that one. I will do the next one in another video.